Now, as we're working through the equations to find out what our calibrated range for this application for the transmitter is, if we put it in this form, instead of having equations all over the page to where I'm going to find out, I'm going to multiply my height here times specific gravity, and I'll find out what my hydrostatic level is over here, and I will multiply 150 inches times 1.3, and I'll have that in another part of my page. And as I start going through here, I have numbers all over it, and when I start the calibration procedure, I don't know which one's which. To keep it organized, I would highly suggest that you create a chart like this. And what this is showing you, that is at 4 milliamps out of the transmitter, this is the hydrostatic pressure. 195 inches of water, H2O, is being applied to the low side. That's because of that wet leg. We have filled that empty leg with that liquid that's 1.3 specific gravity, and it's 150 inches high. So that's on the low side. On the high side of my transmitter, and this is what we're referring to, the high side, at an empty level, this is 0% and that's 100%. At an empty level, I have 0 inches of water column hydrostatic pressure applied to my high side. As I fill this tank and get to the full mark on this, I still have that static 195 inches of water column pressure being exerted on the low side, but the high side has increased to 100 inches of water column. So if I apply these different pressures to my transmitter as I'm bench calibrating it, it will work. It will be set up for this application. I could bench calibrate it for these pressures. I could go out and put it on the vessel, put it into service, and it would read accurately 0 to 100%. This is if I have 2 regulated air sources. If I only have 1 regulated air source, I could use a differential pressure method, because those DP cells only measure the difference in pressure across them anyway. I could use the differential pressure, and the way we derive that is we high minus low. The high pressure, the pressure that's on the high side minus the low side, will equal what our pressures are. Let me write this off to the side. High minus low. So at 4 milliamps, we have 0 for a high, 0 inches of water column, and we subtract 195 inches. We get a net result, or we get an answer of that, which is equal to negative 195 inches of water column. Let me erase that and get that out of the way. And when we go for our 20 milliamps, high minus low, 100 minus 195 equals negative 95 inches H2O. We don't have a negative inches of water column gauge in our lab. What this negative is indicating is that the higher pressure is on the low side. So if we simply put 195 inches of water column on the low side of the transmitter here and set our 0 at 4 milliamps, and we apply 95 inches of water column on our low side, and that's what that negative sign is indicating, that higher pressure is on the low side, and set our range or our span for 20 milliamps, we have just calibrated that transmitter for this application. These negatives, like I said, do not mean that it's a negative pressure. It indicates that that pressure is on the low side of the transmitter.